Construction of transistor. There are many methods are used for the construction of transistor, but mainly two methods are very popular for the construction of transistor. So first, alloy junction transistor. Second, silicon planar transistor. So in this topic we will study only two methods for the construction of transistor. Now first, alloy junction transistor. The formation method of uh, making alloy junction PNP transistor is shown in this figure. A thin layer of germanium about 250 micrometer crystal wafer is taken. Now this thin layer is lightly doped, which act as a base of the transistor. Now indium dots, that means p-type impurities, are taken on the both sides of this vapor and it is heated. The heat should be maintained in such a manner that the temperature should be above the melting point of indium but below the melting point of germanium. Now after heating, the whole assembly cooled down. After cooling, the germanium and indiums are deposited on the both side of wafer, and both side p junctions are produced. So this types of construction is known as a alloy junction transistor. The collector regions is greater than the region of emitter. That means emitter region. So the terminals are taken out from this as each layer. That means emitter, base and collector. Silicon planar transistor. It is a second method to construction of transistor. Now in this method, N-type silicon wafer is used, which works as a collector of the transistor. So now on the entire surface of N-type silicon wafer, silicon dioxide layer is grown whose thickness is approximate 1 micrometer. Now this silicon dioxide is an insulating material which does not allow the impurity enter through it. For making the wafer, the acceptor impurities are diffused in the N-type material. For this, silicon dioxide layer is removed from the area where the base is to be created by photoresist process. Now these boron impurities are exposed in form of vapor is p-type, which is p-type material. Hence these impurities is added in the depth of the material. Now this process is continue up to the depth required of boron in this N-type materials. Now thus the base region of collector is developed. Now next, another silicon dioxide layer is grown on the entire surface of the transistor. Then again the silicon dioxide layer, some portions is removed to produce another wafer of donor impurities. Now the donor impurities, phosphorus, are exposed in terms of vapor and N region is created. Now which creates emitter of the transistor. Now again another silicon dioxide layer is grown on the entire surface of this transistor. Now as shown in this figure, some portions are cut down of the silicon dioxide layer. So now the metal contacts are grooved on this cut section of silicon dioxide layer. Now this whole assembly is placed in the package and three terminals taken out as a emitter, base and